Thanks for joining, everyone. I'm particularly excited about this meetup. We've got a lot more LogRocket meetups coming. Mostly around, we've got a couple TypeScript ones, a React one, and then hopefully if everyone's nice enough, Amit will join us again for another CSS Performance one. I'm really excited about this. I've been trying to figure out like the best balance of SVG animation with pure CSS and making sure it doesn't kill all my readers' browsers. So I'm really excited about this. So yeah, we're joined today by Amit Sheen. He's all over the place nowadays in terms of CSS animations. We're a huge fan of front-end performance. So yeah, and as always, this meetup is brought to you by LogRocket. And in case you've never heard of LogRocket, we're a front-end performance monitoring solution that's really focused just on the client and how things like really resource-intensive CSS animations might impact the user experience. So we combine session replay with front-end performance monitoring, error tracking, and then kind of typical product analytics so you can get a better idea of what's happening in your applications. And I'm quickly just going to kind of show the piece that I think is really relevant to what we're going to be talking about today, which is that client-side monitoring piece. So obviously, as we're shipping lots of really awesome animations, we want to be cognizant of how it's impacting end user experience. So with LogRocket, we can actually proactively monitor how something like a CSS animation is consuming memory, CPU usage, and even maybe crashing the browser from the client side. So we can look at an aggregate and see we've clearly got a spike in memory usage, for instance, here. So I can actually go in to see what part of my application is actually causing that spike in memory usage. So basically now I'm looking kind of at the replay of this person's session, and we are kind of monitoring not only just exactly what they did, but all of those really performance specific metrics on the client. So stuff like page load, cumulative layout shift, and CPU usage, memory usage, everything. So we can see like, if there's a big layout shift here, how is it impacting memory? We have a lot of CSS animation. If it's spiking memory usage, we'll want to implement some of the things that Amit's going to tell us about right now. So that's the end of my ad. And yeah, if you have any questions, let me know in the chat. I'm going to go away now. So thanks a lot.
Thanks, Luke. Great product. Yeah, so it would look your product is looking at the big picture, but today we're going to look at something at more at the animation level itself. So hi everybody, my name is Amit. So just let me share my screen. Yeah, do you see my screen?
Yep.
Yes. Yep. Okay. Yeah, so I think the title of today is pretty self-explanatory. Today we're going to talk about how to use CSS animations and still stay performant and accessible. So let me just start by first doing a very fast introduction of myself. Just like Luke said, I'm a front-end developer. I do a lot of animations, do a lot of CSS. I kind of known from my 3D and perspective stuff. I'm currently working as a front-end developer at Wix. But the main thing that you really need to know about me is that I really love animations. And this is just, I'm going to show you just quick examples of some animations that I did in the past couple of months, all pure CSS. And when I use my animations, I don't really think about performance or accessibility most of the time, because this is just proof of concept. This is just idea. This is just me exploring new things in CSS. But when I do use those animations or any kind of animation on a product that is a real life product, so obviously I do think about performance and accessibility. And people ask me,
yep. Sounds like the audio is clipping. Like the sounds like kind of like staticky, I guess. Do you have a backup mic or?
I'm going to put an earpiece on because I don't have my headphone on. So let's do it
Yeah,
like
let's try that.
and now, do you hear me now better? Look,
Try again.
do you hear me better now?
Seems a little bit better.
How about now?
Yeah, that seems better.
Yeah, okay. So now because I canceled the speaker, so now it's gonna be, I hope it's gonna be better. Yeah, so I'm sorry, I'm just gonna start the last thing I said that oops, let me just restart this video. What I said, I am using, when I'm doing my animations, I don't really think about performance and accessibility again, because this is just ideas and just concepts. But a lot of people ask me about real world life animations. And yes, you should think about performance, and you shouldn't give up performance, and you can use these animations and still stay performant and accessible. And this is what we're gonna talk about today. So let's just jump in, and we're actually going to start with performance. So when you talk about performance, about web performance, when you hear people talking about performance, 9 times out of 10, they're actually talking about loading performance. The loading performance is, I have information on my server, the client's asking for this information, I need to give him this information as fast and as smart as possible, because it's not only as fast, you need to know what type of information to send when and so on. And there's a lot of methods of how to improve the loading performance, but the overall purpose is to reduce the overall load time and to make the site usable as soon as possible. Now, obviously, loading performance is very, very important, but this is not what we're going to talk about today. Today, we're going to talk about runtime performance. And runtime performance is all about the FPS. It's the frame per second. We need the frame per second to be high. And when we have a high frame rate, so the animation works great. If we have a low frame rate, so the animation looks choppy, we get poor user experience, and we don't want it. So what is it? What is this frame per second? Why do we? Why is it taking him so long? What is it? So let's imagine. Let's start at the basic. Okay, let's imagine this line is 1 second long. Okay. Now, a normal screen refresh 60 times a second, and some devices nowadays can refresh 120 times a second, but it's not that common yet, and not everything is supported for 120 FPS. So for now, let's talk about 60 frames per second. That means that we need to divide this line into 60 little segments, and each one of these segments is just a frame, which means that each frame is just under 16.7 milliseconds. And that's not a long time. It's a very, very short time. And we're asking the browser to do a lot of things inside this 16.7 milliseconds. In fact, we ask him to do all the scripting, all the rendering, and the painting. So let's understand what each of them means. Scripting, I'm not going to go too much into scripting because we're talking about CSS animations. Luke, you wanted to say something?
Yeah, could you just try to unplug and replug your mic in? Some people are still getting some feedback or like staticky.
Really? Ooh.
The old Google machine says sometimes just replugging back in helps.
What about now?
That seems better.
Seems better?
Yeah. Yeah, we'll keep going.
Okay. Yeah, so I was talking about, I'm sorry about it, by the way. I normally don't have a lot of problem with this mic. It's actually kind of a new mic. I hope everything here is okay. Yeah, so I was talking about scripting. As I said, I'm not going to talk about too much about scripting today because we're talking about CSS animations. But if you are using JavaScript, for example, to do request animation frame and changes an element on each frame, so this is something that takes time. You're asking the browser to do calculation on each frame. The second phase is the rendering, because after we have changed the style or an element, whether it's through scripting or with CSS, there's actually three things that happens inside the rendering process. The first thing that it needs to recalculate the style. If we change the style, so it would recalculate the style. And the second thing, if we change something that might change the layout, so for example, because I have an HTML page and my HTML page is built out of boxes, box models. So when a box model changes, for example, the width or the height of an element, you're actually changing the flow of the page. So if the recalculated style changed something that might affect the flow of the page, so it will trigger a layout function, also called a reflow. And a reflow, I marked it in red because it's very, very expensive in terms of performance. And the last thing that's going to do in the rendering tree is update the layer tree. And we're going to talk about layers in a few minutes. So after the rendering part, the last thing that it does, again, in every frame, is painting. Is actually taking this information, the raw data, and turning it into pixels and pushing it to the screen. And again, this painting process is, again, something that is kind of cost a lot of time. So it's expensive in terms of time. Now, the guys that build the browsers are obviously very, very smart. So they have all these optimization things that going on. So the browser is not doing all of those things every frame, because in fact, if you're looking at a static page and there is no change, so great. So there is no scripting, there is no rendering, there is no paint. So we get the max frame rate, and that's great. But we're not talking about static websites, we're talking about animations. And when you are doing animations, each one of those parts takes time. And if the amount of time that each frame is longer than 16.7, then you get longer frames, meaning low frame rate. And again, low frame rate means choppy animations and bad user experience, and we don't want it. So the first tip and the main tip, the tip number one that you're going to get regarding CSS animations, performance in CSS animations, is avoid using properties that triggers a reflow or a repaint. So, okay, it sounds reasonable, but which elements triggers what? You can actually use a bit of common sense, because if you're triggering something that changes, that affects other elements, it would cause a reflow. And if you change something that causes a visual change on the screen, it will cause a repaint. So you can use some common sense, or you can use this tool that is called CSS Triggers. It's a great tool by Paul and Soma, I think. Sua. Yeah. So it's just a list of every CSS animation that you can change, and what it triggers on each one of the browsers. Now you do have a layout, which is a reflow, paint, and the composite. Now I'm going to talk about composite in the next slide, but for now, all you need to know is that everything triggers composite. Okay, so let's look at layout and paint. And we talked about width earlier, so let's look at the width element. So you can see that the width element triggers both the reflow and the repaint, because the width element, as you can see, it alerts the geometry of the element, it affects the position and size of other elements, so the browser needs to perform layout operations. Of course, after layout operations, you need to do the paint and then the composite. So this is the width. But if we take something like, for example, let's take the background color. Here. So the background color doesn't trigger the geometry changes, because it only affects the same element. So it only causes painting. So in terms of performance, it would be much better, and you're going to ask the browser to do much less. But if you look at something like transform, for example, transform, you can see that transform triggers not a repaint nor a reflow. And so it's only a composite, so it's very, very high and very, very performant. So let's look at some examples. And while we do it, we can also see how to work with the dev tools. Now, I'm working in Chrome, but there are also the same things in other browsers, just I'm used to working with Chrome. So here I have just a very simple page of a few paragraphs and an image. And if we go to the elements, we can see that all I have is just an animated div that I'm animating its height. And right here in the dev tools, we have the console drawer, and in the console drawer, there's the rendering tab, and there's a few things that you can use right here in the rendering tab. First of all, is the frame state. So you can see what is your frame per second right now. So you can see it's pretty much close to 60. And this is a good place to say, I said that animating the height, it's not performant, and it's not, but I'm still on 60 frames per second, because when I'm saying that it's not performant, it's still okay if this is the only thing that you're animating. But if you have 30 elements that you're animating their heights, then you have a problem. So it's just figuring out what's on your page and how many elements on your page. And if it's not too many, so you can use things that cause reflows, is just better to avoid them. And one more thing that you have right here in the rendering panel is the paint flashing. And the paint flashing is actually marks all the things that is getting repainted in green. And now you can actually see the problem that I'm asking the browser not just to repaint the element that I'm animating, I'm asking him to repaint everything that is beneath it. So right now I only have 2 paragraphs, but it's, again, it depends on what's on your page. And because I'm actually making the page size difference, I'm also repainting the scroll bar. So this is the rendering tab, but up here we also have the performance tab, and you should absolutely use it if you want to explore the performance of your animations. You just click on the performance tab. Right now it's empty. What you need to do is actually record the animation. I'm going to do a record just for a few seconds, and I'm going to stop it. And here we go. We have a summary right here of how much time we done the rendering and the painting. The system and the idle is, we're not going to do it right now because this is what the system uses. But right here inside of the frames, I can actually zoom in to each one of the frames, and I'm going to see exactly what happened on each frame. And you can see it started by recalculated the style, just like we said. And because we're changing the height, it then did the layout, the reflow, because there was a layout operation. And then he updated the layout tree. Afterwards, he's done the paint and the composite. So you can actually see if you do have some choppy animations, go to the performance tab, record your animations, and you can dive in and see how much time each thing took. And once you know what the problem is, it's much easier to solve it. So let's see another example. And this example, as I mentioned earlier, only animates only the background color. So let's come here again to the performance tab. I'm going to record this animation. Again, I'm just going to record 3 seconds of it. And now you can also see there's also rendering here, but you can see that the rendering is already smaller. It took much less percentage of the time relative to the paint, because if we're going to zoom in right to a frame right here, and again, by the way, each thing is a frame, right? So I'm just going to go for a single frame, and you can see that there is still a rendering process that recalculates the style, but because there was no reflow, then it just updated the layer tree. So this animation is actually much more performant. Again, I've asked the browser to perform less calculation. And the last animation, it's this one. Oh, this is something that is rotating in 3D. This must take a lot of work out of the browser, right? Well, again, this is transform. And if I'll record 3 seconds of this animation, you're actually going to see that there is no rendering and no paint because the transform doesn't render, doesn't trigger not the reflow and not the repaint. That is why, as I said, that's why this is the best option to animate, because it doesn't trigger no reflow or repaint. So okay, and now the question is actually, if it's okay, I understand why it doesn't trigger the reflow, because it doesn't affect the other things right here in on the page. But why doesn't it triggers the paint? Because pixels are moving, right? Well, it doesn't trigger the paint because it does trigger the composite. And this is when we talk about web performance, FPS performance, we've got to understand the concepts of layers and compositing. And I know that layers and compositing sounds really boring, so let's give it the more sexy title of hardware accelerated animation, because this is actually what it is. Using layers, this is the way of the browser to use the GPU, or actually to use the GPU's ability to compose layers very, very fast. This is what the GPU does. Its GPU is a processor that is meant to do graphic operations, and it can composite layers really, really fast. So what the browser does is actually take the element, the rotating element that is transforming out to a different layer. Then the GPU perform all the transforms right there on the new layer, and then composite the layers back together. And this is much, much faster because there's no paint, there's nothing, because the layers that are not animating are not changing. So, okay, so maybe some of you are asking, why not divide everything into layers and just work with layers? Well, no, because first of all, working with too many layers will cost some time eventually, will be time consuming. But the other reason is, again, the flow, because if I'm changing something that affects the flow, that affects other elements, I can't put that element on a different layer because it needs to be on the same layer as the other element that it affects. That meaning that the only properties, the only elements that can be on different layers are those that the property that you animate doesn't depend on or affect the document flow or cost a repaint, which means that the only thing that can be animated on a different layer, that can be GPU accelerated, is transform and opacity. And just in a little side note, there are some filter functions that can also be moved to a different layer and can be GPU accelerated. But I read about it, and there are some concerns about some iffy browser support. So I didn't put it right here on the slide. But theoretically, there is some filter functions that can also be GPU accelerated. So this is the concept, and the great thing about today's web browsers is that we can actually see it. So let's go back to this first example. And right here, right next to the performance tab, we have the layers tab. And by the way, if you don't have it in your browser, you can right here in this 3 dots, there's more tools, and then there's layers. And right here, you can see the layers. And as I said, now all of this this animation have to be on a single layer, so you can actually see, if I move it right here, you can see that it's just one layer. I hope that you see it well enough. Let's look at the second example. Let's go to that layer. Again, it's the same thing, because right now doesn't really depend on one another, but there's no, there are repaints, so they can't be moved to a different layer. You can see again, it's one layer. But let's go to the third example. And when I go to the third example and go to the layer, so now when I move it, you can actually see that each one of them is in a different level, is in a different layer. And then it only moves this layer. This is the only layer that is actually being animated. And again, it's being animated right here by the GPU. And then the GPU composites everything. That is why this animation is much more efficient and much more performant than this one, for example. And when I talk about layers and compositing, there's always the question of will change. And the question is, should I use will change? Now that we understand what layers is, what will change does is actually tell the browser what the animation is going to be, and then the browser knows if it can turn the animation, remove the object to a different layer or not. But when people ask me if they should use it, I say no, not as a default, because if you go to the MDN, for example, for will change, you will probably see this warning that says that will change is only intended to be used as last resort. As I said earlier, the guys that build the browsers are very smart and they already know what is going to change. But in some cases, if you're loading the animations later from a different file or something, then yes, you can use will change. I'm not saying don't use it. I'm only saying don't use it as a default, because I know of a lot of people just use it as a default. And while we're in the subject of warnings, let's talk about the bad news. And the bad news is that sometimes your animation will be slow. The fact is that the browser has their limits, and sometimes animations have like a way, if you're using 1000 divs animations and you're using shadow boxes and things, so yeah, things might become a bit heavy. And sometimes you get a design request from the designer, and as I said, designers don't care about, they do care about performance, but when they design things, they don't think about performance. So they think about what they want to see. But it's your job as a developer to say, okay, but this is too heavy for the page because we have too many elements, so let's go a different way. For example, if I have just an info card with the read more, I can suggest that when you click read more, instead of opening the more information beneath and animate the height, we can actually rotate the card 180 degrees and have the information in the back. This transition is going to be much more efficient and much more performant, as we just saw. But the bottom line is for you to stay performant. And of course, as we saw, stay performant, it's all about the FPS. Check your FPS and keep it just around 60. If it's too low, if it's 58, it's okay, but too low, you're gonna get choppy really, really fast. To do that, as I said, first of all, avoid reflows and repaints as much as possible if you are using a large number of animations. And if you can, only use transforms and opacity. By the way, one of the great things about most of the things that I do, or most of the 3D things that I do, is that it's all transforms. So relatively, it's not not performant because the GPU does most of the lifting. Use the dev tools, which I just show you a few things in Chrome, but there is a lot of things in all of the browsers. But check your FPS. If you see a frame drop, check why it happens. Go to the Performant tab and check and record your animation and check what happens in each frame. Watch the paint flash, because it can really help you to see what's changed inside the page. Sometimes animations triggers changes in bigger containers, so it's just over calculating because they're calculating on a big layer. So you can see all of these through the dev tools, and of course use the layer tool to see if your animations need to be in a different layer. And the last thing, of course, is know your limit, because as I said, eventually browsers do have limit power of calculation that they can do in this 16.7 millisecond. So yeah, so far for performance. But now let's go to the end part. And I said, let's talk about how to do CSS animations and stay performant and accessible. And accessibility, just like performance, you really shouldn't give up on accessibility. It's really, really important. And it's not that difficulty, but there are some basic rules that you need to remember. And we're going to see an example for each one of them in a second. The first one might sound a bit weird, but you need to watch out for unreachable content. If you are using animations, sometimes like in buttons and in inputs or something, sometimes these inputs and buttons are nested inside of some divs because you need to animate them and move them. So when you are using these types of animations, if you're doing something weird, work with screen readers and make sure that your content is readable with screen readers. And if not, just use area labels where needed, if needed. Do what needed in order to keep the content reachable for any type of system technology. The second thing is don't forget the focus state, and actually don't forget everything that is keyboard navigation. So actually, let's look at an example here. This is a simple example I made a couple of months ago. This is just a checkbox element, and it uses 3D. And when I click on the checkbox, it moves like this. So it's nice. So first of all, the first thing I said is watch for unreachable content. As you can see here, the cube has this div and a lot of divs in it, and a content and a span, and it looks a bit weird. So we added an area label. You need to check if you're doing something like this one. I can tell you, for example, this check button, it's an after element, pseudo element. But for example, if instead of the check, we'll have a text here, so the text wouldn't be readable for by screen readers. Of course, it's going to look horrible, but you understand the concept that this text, even though it's visual, we can see it, it's not visual to screen readers. So this is just something to note. And the other thing, as I said, is keyboard navigation. So when I click it, it moves, but it also changes. When I click the tab, I can see that I have the space, the outline. And when I click the space bar, so it changes. So it's absolutely accessible, even if you are using keyboard navigation. So this is two things that you really need to look after when you're doing animations. And the third thing, and the most important thing, is to not do animations. Some people can't see animations, so you really need to use preferred reduced motion. And again, let's see it live here. If you go to my code, you can see right here in the bottom that I have media preferred reduced motion. And in my case, I decided to set the animation play state to pause. And of course, I did important. And if we open the if we open the this rendering bar rendering tab again, there's also, you can also emulate. Right here, you can emulate all kinds of things, but you can also emulate the preferred reduced motion. So if I'm going to emulate preferred reduced motion to reduced, like this. Okay, so now when I click it, you can still see the click, and when I leave it, it will change. There is still some animation, some sort of feedback, but it's not have the same animation because we set animation to reduced. And if I'll change it back, so we can see the animation. So using preferred reduced motion is very important. Don't forget about that. And hopefully now you too can use CSS animation and stay performant and accessible. Again, hopefully. And thank you all for listening. I hope I was clear enough. And if you do have any questions, now it's the time.
Awesome.
And I'm sorry about the mic troubles.
It resolved totally fine. So there's a little fuzzy up front, but the rest sounded great. Thanks. That was awesome. The CSS Triggers site is amazing. Yeah, what a useful tool. Thanks for sharing. We do have some questions.
I see a question by Saib Adam.
Yeah, that was that first one. And I think what he's trying to say is like when you're kind of testing stuff, in your browser, is it best to kind of not have a bunch of tabs open?
Well, yes and no. Let's open. It's not this one. So the fact that I have here a few tabs open, it doesn't affect the frame rate because the browser doesn't render anything that is off the tab. It does affect things like memory usage and all the things that you talk about before that, but it doesn't have any effect on the FPS.
Okay, interesting. And I'd also say like most of your end users actually have a million tabs open, so it might be good to develop stuff with a bunch of stuff.
I have, if you can see, I have like two windows or two browser windows open. The other one also have a few tabs on it, so it doesn't really matter. I can tell you when I do, sometimes I do like presentations about 3D animations, not performance, just about 3D animations, and I have a lot of examples open, like over 15 live examples, and they're running like off of CodePen, some off of CodePen, some locally, and they're heavy animations. Never had a problem.
Yeah, I guess generally there's a couple questions about like when to use video, when to use like a JavaScript library versus just native CSS. I have a feeling I already know your answer, but yeah.
Well, if you know my answer, so answer. No, because my answer is it's like it's the stupid answer that it depends.
Yeah.
It obviously depends because there's no right answer. A lot of people like ask me if Lottie is a good library, or should I use SVG? What do you want to do? Like if you want to just do like a simple text animation, yeah, CSS would be great. But maybe if you need specific, I don't know, specific feature, then you should use SVG. But maybe if you are using some kind of JavaScript rendering, so maybe just use GSAP or so, in Canvas. So there's a lot of different ways and different answers for different needs. There's no really right one answer.
Yeah. And then someone asked, like, when you just, in that last example, when you were moving through things with the keyboard versus the mouse, how did you, is there anything in particular you were doing to make that function well? Or was that just native like inputs?
Well, so I just used labels, and labels have an index. They're getting indexed as tab elements naturally. But if you are using some kind of like a div to wrap everything up, you can add a tab index attribute to it, and the tab index get a number, so you can actually arrange them by order. And there are different solutions to all of them, but the main thing is first, you need to know that you need it. And once you know that you need it, finding the correct answer and the correct way to get it, it's very, very simple.
Yeah, awesome. And then on the prefers reduced animation, I'm curious about this too. Like, do you know how it, like what aspects it uses to tone down the animation? Like, does it?
Well, yeah, actually, the one thing that you really need to remember is when you talk about reduced motion, it is a reduced motion and not stop motion. So a lot of people say everything is paused, not even like click active on Hoover effects. No, use Hoover effects and use active and use micro interactions where you need them, but tone it down. There is no specific rule about what toning it down means. But it really needs to be very, very calm. There is, I forgot to mention, but there is a great article by Michelle Barker called Respecting Users' Motion Preferences, which is, it's a great article that covers this entire topic from top to bottom, not just how to do it, but in different cases. And one of the things that she says there, and I absolutely agree with it, that it's actually should be the other way around. The animation should be stopped as a default and only active if the reduced motion is set to no preferences. Because in some browsers, this preference is not available, and there are still people that using that browser that can't use that still prefers reduced motion.
Okay. So yeah, follow up on that. So you were using a totally different animation for the prefers reduced motion query. The only rule, yeah.
So no, for me, what I've done is just what I said is just in reduced motion, I've just said the animation state is paused. This is one way to do it. Other way to do it is just to set the animation time to 0, the animation duration, excuse me, to 0. Other way to do it is just not making any animation, or just moving it to some sort of transform, just just to ease something in. There are a lot of different ways. Again, it depends on what your style is, what the style of the design of your site is.
Awesome. And that looks about it. Yeah, a couple more questions on like SVG versus pure CSS, but
I can tell you, like in my new jobs, we work a lot with SVG. So I'm really diving into it. I can't say that there's a real difference, because there is obviously a real difference, but eventually it's CSS animations on whether it's on a DOM element or an SVG element. Most people say that SVG is more performant. I don't know yet to say, but again, it really depends.
cool. Let's see if I missed anything.
I see another.
I will send this around everyone with the links to the code pens and maybe some other blog posts Amit's written. Oh yeah, this one I was curious about. I think there's some confusion around like the new CSS feature layers versus like just the index. Like, what were you referring to earlier?
No, the layer that I was talking to has nothing to do with the layer feature of the new CSS.
Yeah, okay.
It has nothing to do with it. This is the layers that the GPU uses in order to render the page, and this is layers to scope things inside CSS. Two completely different topics, same word.
I wish they chose a similar but not exactly that word, because it does there are some people
it's two different worlds. What we're talking about now, it's inside of the browser, and this is CSS. I think it's okay. I think it makes sense. And by the way, actually the layers in the browsers is actually maybe a bit more confusing, because it's not really layers. You can't think of them like Z-index layers. It's one behind the others. All of the layers live in the same plane. It's just it's virtual layers that the browser, that the GPU just treat each one of the elements, each layer as a different plane. But again, it's not like a Z-index. The layers that the CPU usage. So actually, the layers in the CSS makes more sense than the layers in the GPU, but who cares?
And then someone asked about CSS has pseudo selector. That's a topic for another talk.
Yeah, I could talk about has for 2 more hours.
Maybe that's our next one.
I can say that it is just for like in 2 sentences. I can say it's something that I've been waiting for ever since I've been starting doing CSS, and the simplest way of explaining it is just a parent selector, but again, it's so much more than that. But it does mean that you can change the direction of the way we look at CSS, because it's not just, oh, this is the element I selected, now I can select everything after it or inside of it. We can now select the children according to what happens to its parent. Right. So that's great.
I think we've got our next topic. Great. Awesome. I think
fine with me. I see another question from Adam, from Saib. Will mobile browser and PC browsers react differently? Absolutely, because not because of the yes, because of the browser, but mostly because of the hardware that they're built upon. Most of the time, mobile hardware is slower and weaker than PC browsers, PC hardware. So yeah, the browser will react differently. And there is some difference in support also, but today it's very mild. But yes, there is some difference in support, but not in the things that we talked about today.
All right. Well, thanks a ton, Amit. That was great. I'm going to stop animating widths now. I didn't know how much damage I was doing. So yeah, thanks a bunch. And yeah, I think we've got our next topic idea. Yeah, the new meetups are going to be on the LogRocket blog. There's like a meetups tab on the header, and I'll send this around to everyone within the next hour or two. So yeah, thanks for joining. Thanks, Amit. We'll see you next time.
Thank you.
Bye.
Bye, guys.